Smells like they cut the grass out there, Jack. Does it look like they cut it? Smells fresh, fresh cut grass. All right, so today is the easier of the 2 days of the conic that was introduced yesterday. Yesterday was the day of all that information, all the parts of the ellipse, and then of course the standard form. A lot of work involved in graphing an ellipse. So today we are going to talk about number 45. That one was kind of special. It did have some fractions in it, and I want to understand what happens with those fractions, especially with the standard form of the equation. So we'll look at number 45. We'll talk about another problem where if you're given the information, can we create the standard form by using parts of the ellipse? So if I have the foci, if I have the vertices, or if I have a major or minor axis, can we create the standard equation of the ellipse? And then the last thing we're going to talk about today is something called eccentricity. And hopefully you ignored that part because we didn't talk about it yesterday. So we'll talk about the eccentricity. Each conic actually has eccentricity, and it's something that we can look at to help kind of decide the type of conic that it is based off of the eccentricity. But we'll talk about what that means and what it does with your graphs, how it affects the shape. So it does affect the shape of the graph, and we'll look at that today. So tomorrow we're at home, and tomorrow will be a day to kind of pull the circle, the parabola, and the ellipse together. So on Thursday, we'll learn the last conic, which is the hyperbola. And that'll be, again, like the day of a lot of information. And then Friday, we'll kind of summarize the conic sections. We'll review on Monday, and then you'll have a test next Tuesday. So a week from today, a test on conics. And then we'll start the last chapter, which is on limits and a derivative. It is really totally an intro to calculus. Yeah. The last chapter of this entire class will start next week.
This is the second to last.
This is the second to last chapter. Yeah. Yeah. So, and we'll see where that, like, we will get through the last chapter, no problem. There are a couple of things that I'm still hoping to do with you to show you different types of equations, more calculator based, and we'll see how much time is left after we talk about limits and derivatives, the last chapter. But yes, the last chapter. So you have the test on this chapter, and then the last chapter I think has like a big quiz and a test, and then that'll pretty much be it. Like we have like 5 weeks. Next week is May 3rd is Monday, I think. Just crazy. So not a lot of time left, really. Last 2 weeks, I think the second to last week was a Tuesday of election day, and then the last week of school is a 3.5 day week. And today's Joe's birthday. Happy birthday, Joe. Lots of birthdays this week. I have a whole bunch of birthdays on Thursday too. Okay, so looking at number 45, if my screen pops up, there we go. 45 was a pretty big problem. 16x squared plus 25y squared minus 32x plus 50y plus 16 equals 0. So this question wanted you to find all the information and graph the ellipse. And to start off doing that, Jenny, what would you do to start? Yeah, so combine those squared terms so that they're at least together next to each other. Move the 16 to the other side. So we'll take that. And then I'm going to try and just save a step, Jenny. What would you take out of the x squared term? The 16, which leaves you with? And then looking at the y. And then y squared plus 2y. So individually, you're pulling out the coefficient of the x squared. You're pulling out the coefficient of the y squared. Those coefficients are different. That's what makes this an ellipse. If they're the same, then it's a circle. because a circle is the same all the way around, but an ellipse is wider in one direction. So point out those coefficients individually from the x terms and the y terms. So when you complete the square, we know with the first, we would add a 1. But on the other side, when you take 16 times 1, you're adding 16. Don't forget that part. So some of you with the circle and parabola worksheet forgot if you take out a coefficient, that coefficient does have to multiply by the number inside when you completed the square. For the next one, we have y squared plus 2y. We would also add a 1, but on the other side, we're adding 25. So, Kaden, what does this look like when you factor it out? And then to get it in standard form, what did you do, Kaden? Yeah, you're going to divide by 25. So for standard form, for an ellipse, it's supposed to be equal to 1. So whatever number's on the right, you have to divide that by that number on the right. On the left side, I see 25 divided by 25. I mean, that becomes 1. So you would have 1 or y plus 1 squared. I'm going to put a 1 underneath there just so that I have a number to represent my a squared or b squared term. So that divides out evenly. I'm not sure where my 5 went with my 25 here. But the 16/25 does not divide out evenly. And all the other problems that you had for your homework did, it reduced. So yesterday we had 4/16, which reduced to a 1/4. For this to be in standard form, you cannot have a coefficient in front of that quantity that's squared. So that 16 cannot stay there. That 16 really does have to be part of the squared term in the denominator. So if I'm multiplying the numerator by 16, but that 16 cannot remain in the numerator, how can you take it out of the numerator, Darby? Yeah, so multiply by the reciprocal. So if there's 16 there, if I multiply by 1/16, then the numerator is going to cancel and that 16 is gone. So now we have x minus 1 squared. And then the denominator becomes 25/16. So anytime you're multiplying by a value in the numerator, you are really dividing by that value in the denominator. So kind of thinking you're multiplying by the reciprocal, multiplying by the reciprocal. But your entire number must be in the denominator because that represents your a squared or b squared term. For it to be standard form, you cannot have anything in the numerator in front. So no coefficients in the front. So we have y minus 1 quantity squared over 25/16, y plus 1 quantity squared over 1, and then that's equal to 1. So looking at this equation, Peter, how do you know if it's a vertical or a horizontal ellipse? Yeah, so 25/16 is bigger than 1. So the bigger number is with x. Therefore, it's a horizontal plane. Questions on that? So after you know that it's horizontal, I'm just going to list our numbers that we have to work with. So the bigger number is the a squared term. 25/16 is a squared. However, you need a for the vertices. And Peter, the a value is 5/4. So the square root of that number. So you can't use 25/16. because the distance from the center to one vertex is a, not a squared. And then b, Peter, would just be 1. And then to find c, the formula for c is c squared equals a squared minus b squared. So you have 25/16 minus 1 or minus 16/16. And that makes 9/16. So that really is 3/4. So yes, you have evil fractions. You got through all the homework without having fractions except the last one. So A is 5/4, B is 1, and C is 3/4. Questions? So let's go back. You're asked to find the center, the vertices, and the foci. So Leah, looking at this equation, what is our center? Oh, 1, -1. So +1, -1. Yep. So we have 1, 1. Peter said it's horizontal. So that means my X has to change. So when you go to find your vertices, you're taking the H from the center and adding or subtracting A. Nothing's happening with K because it's a horizontal graph. So 1 plus or minus 5/4. How you find those vertices. So 1 plus 5/4, Hannah, would be? And 1 minus 5/4 is? Nice. So think of this as really 4/4. So 4/4 plus 5/4, 4/4 minus 5/4. So there's two vertices, 9/4 and -1/4. And again, it's the X that's changing there. And then the other thing we need to find are those foci values. And to get those, again, it's still horizontal. So you're using C. Foci has a C in it. So you're still taking that same 1, but we're adding 3/4. So Kaden, our foci values would be at 1 plus 3/4, which is? Yeah. So 7/4 and then 1/4. So I have my center at 1, -1. That's nice. And then our vertices are at fractions because the A is 5/4. The foci are at fractional values because the C is 3/4. Questions? There it goes. A little bit of a delay with that wonderful Apple TV. Not sure how wonderful the Apple TV is. It's old. Anybody have a sibling that's still in elementary school? They have those fancy boards. And why did they get them? I feel like I mean, I'm probably not, but I would never want to teach elementary school. So my 2 children were enough elementary students when they were in my house and their friends were in my house. That was all I needed. I'm good being a high school teacher. I did go in their classrooms and help out a lot, just so that you all know. I don't totally hate elementary kids. Just like teaching you guys instead. Come on. Well, hopefully you can figure out how to graph this because I think my Apple TV is frozen. See if I can pop off and get it back on. Okay.
Are you able to restart the Apple TV itself?
I am, yes. It takes like 5 minutes, Jack. Stupid Apple TV. All right, so graph it, make sure you're using the vertices, the foci, the center. I need to find that little thing. Here it is. And then your B value would be the other direction. That would be the vertical direction. Here at home, I'm having Apple TV problems, so you're just gonna have to bear with me here. Are you impressed that I remembered where to find that? Are there questions on 45? Everybody feel a little better with number 45? Okay. So if you want to look in your pocket while my Apple TV is rebooting, look on page 12. The question that I'm looking at on page 12 says, find the standard form of the equation of the ellipse having foci at 0, 1, and 4, 1, and then a major axis of length 6. See if you can try and like start that problem. At least think about what could you do to write a standard form of an equation if you're given foci values. So how would that help? Would you know? All right, it wasn't quite 5 minutes, Jack. If it works. Come on, buddy. Thanks for reminding me that I could restart it. All right, so looking at this problem, find the standard form of the equation if the foci are at 0, 1, and 4, 1. Let's start with that information first. What's probably the easiest thing, Darby, to do with that information? Yeah, so looking at the axis, if the x is changing, then it's horizontal. So whatever variable changes gives you the direction of the ellipse. So x is changing, that means the graph is moving horizontally. So this is a horizontal graph. When it's horizontal, we need to have the bigger number under x. Are you serious? So what else could we do? We know it's horizontal. Peter? Yeah, so he's saying the K value, since this number here is 1, that's going to be the value of K because the Y isn't changing. It's the X that is changing. So we would know that the K value is 1. What else could you just do? Like, what's the easiest thing you could do with those 2 points? Easiest thing, so that you're not even thinking too hard. Hannah? You could graph them. Yeah, so if you're not sure what's going on, you can make yourself a little graph. You don't have to. But we can plot these points. So we have a value at 0, 1, and we have a value at 4, 1. So Peter said that the K value should be a positive 1 because that's the value that wasn't changing since this is horizontal. K is going to be 1. Hannah, what would the H value be then?
Would it be
So where would the center be located with respect to those foci?
vector?
Yeah. So if I want to find the center means it's in the middle of any pair of points that you graph. So it's in the middle of the vertices, it's in the middle of the foci. It's in the middle, it's the center. So the middle of this graph is at 2, 1. So by plotting those foci values, you can see that the center is at 2, 1. You didn't want to plot them, you can look at the points and say, I have a point at 0, 1, we have a point at 4, 1. What's the middle of those points? You're finding the center. So we know the center now, besides just the K value, we now know H as well. So we can plug that into our equation. The numerator is going to say x minus 2 quantity squared, y minus 1 quantity squared equals 1. So we now know the numerator. What is the distance from the center to a focus? What is that distance? Peter? And that too represents which of the variables that we've been working with for an ellipse. Yeah, so C is equal to 2. So the distance from the center to the focus is a distance of 2. That represents C. So we know C is equal to 2. What other information is given? Darby? The major axis has a length of 6. That's the entire width of the ellipse. So from vertex to vertex, the whole thing is 6. Darby, what does that help you find? Yeah, that helps you find the vertices. So from one vertex to the other vertex, we should have a distance of 6, which means if I start at the center and if I go 3 to the left and 3 to the right, I would have the vertices. The whole distance is 6. That's the major axis. That's how wide your graph is. So from one vertex to the other is a distance of 6. That's also my A value. Half of that is A. So to get from the center to one vertex, I would go the distance of 3. So the major axis is 2A. Double A. A is one distance from the center to one vertex. So if I double that, I get the entire length of the major axis. So we said this was horizontal. That means my A value is 3. When you square that, it's 9. And that 9 goes underneath the X term because it's horizontal. So again, the foci gave us the C value. The distance from the center to one focus is C. The distance from the center to one vertex is A. So now I have C and we have A. But we still need the B squared term, the number underneath here. Cole, how could we find that? Yeah, oops, that's a minus. So that formula we use to find C, but if you know C, and I square it, I can also find B. So Cole, B squared would be equal to, or just, so you gave me B. B is the square root of 5. B squared would just be 5. So now we have our standard equation by finding the C using the focus, finding A using the major axis. Half of the major axis is A. And then using that formula, C squared equals A squared minus B squared. I solve for B squared because that's the number that goes underneath Y. Then we have our standard form of our equation. Any questions? So the very last thing that we're going to kind of define here is eccentricity. And it says the eccentricity is the flatness of the ellipse. So how narrow is it, or is it more circular? Does it look almost like a circle? And I believe one of the questions from last night, number 41 was more like circular looking than some of the other graphs. 37, 38, 39 were all like long, elongated would be a good word to use for that. So to find the eccentricity for an ellipse, eccentricity is E, makes sense to use an E. It's the ratio of the C to A, comparing the distance from the center to the focus versus the distance from the center to my vertex. If E is close to 0, then our ellipse is more circular. And that would have been like number 41. So 41 was close to being a circle. It still wasn't. The one distance is a little bigger than the other. But if E is close to 0, our ellipse looks circular. And the second statement, if E is close to 1, then we call our ellipse elongated. So it's going to be more oval looking. So do you have an oval? Oh. Or, there we go. Is it more circular? Which that one actually picked up a circle. So for an ellipse, it's the flatness of an ellipse. We take the ratio of C over A. If that number is close to 0, it's a circular ellipse. If that number is close to 1, it's more elongated. That number also must be less than 1. When it's less than 1, it makes an ellipse. So that would be all the notes and the concepts that we're going to go over today. You have about 10 minutes, 11 minutes. And I do have the books open over here where I will put one up on the desk. The homework today is given the information of the graph, and you create the equation. So you're not finding the vertices, the foci, the center. Instead, you're finding standard form. And that standard form is going to be found by using the information that you're given. So the homework is numbers 19 to 35 odd. And then number 28, because I like number 28 and 19 to 35 didn't have an example like number 28 in that group. So 19 to 35 odd, and then number 28. And again, you have about 10 minutes. So a book is open on the counter over here. There's a book open on the front desk. Feel free to take a picture. You might already have this from yesterday too, depending on what page you took a picture of.